We're in Brown County, Ohio, and common soils that are here are the Claremont soils and the Avonbergs. They're generally till-derived soils from the Illinoisan glaciers, and they have a large cap of loess, windblown silts that have been moved in since the glaciations. These soils tend to have several problems. One is infiltration. Water does not move into the soil very easily, especially when it's been farmed a lot with not a lot of conservation practices. This is actually a pretty good example of how cover crops and other systems can change soils for the good. A more typical Claremont will not have soil structure like you see here, with more granular and small BB size structure. It's a normal Claremont would have more of a platy structure and probably not this dark of a surface. As you can see here, this soil is fairly dark at the surface because of organic matter that has come down through the roots from the crops and the cover crops. I believe this farm has had covers somewhere around 5 out of 10 years, maybe a little bit more. So it's really starting to show some improvement because of that. To show a little bit of the difference in the soil horizons here, again, here's kind of the break of your topsoil or your A horizon. And the A, actually, I would break it out into two separate. You can see that the surface has more of a granular structure to it, and as you go down, you start losing that nice granular structure. It starts to get more subangular blocky. Something else you can maybe see on that, there are reds and grays that show up here. This is where iron has been reduced, leaving the gray, and then redeposited oxides. That's the iron. It's a rusting reaction that's happening in the soil. It's a pretty good indicator of where your water level can be for a good portion of the year. As you move out of the A horizon, again I said A1 and A2, but you're moving into more of a B horizon or an alluvial soil, or horizon, excuse me. You can see where the clays have moved down in, your texture begins to get more clayey. As the water's moved the clay down, it starts to pick up. Again, the structure is not nearly as nice as you had in the A. It starts to get much more blocky, but the texture is still silty, much like it was up here. Is more like a silty clay loam, maybe, something like that, down to probably stays about the same. And you can start to really see a break somewhere around 20 inches or so, 18 to 20. The soil really begins to lose structure and pick up clay. This is where your reds and grays really start to pop. Your clay has started to rise, and really there's not much structure. These break out into large prisms, or what we call, well, some are prismatic, some are more of a massive structure. Just saying that there's not a lot of root penetration, not a lot of water infiltration working here. And again, as your clay picks up, as you get closer down to 40 inches or so, the clay really takes a jump, and the reds and grays become even more pronounced. Again, this is a case where the water is not moving very fast, and you've got the oxidation reduction reactions going on. The clay's picking up here also because this is the till that was originally laid down in the Illinoisan glaciation. One way to improve soil quality in this area is, again, adding organic matter to these soils. These are lusses that have been blown in, silts that were blown in, and as a result, they have a couple of problems. One, they tend to crust and compact very easily. The crusting will happen when bare soil has rainfall on it, and it just kind of pulls it up to the surface and seals over, so water tends to shed off of the soil instead of infiltrating down in through the profile. Another problem is there's usually not a lot of organic matter in these soils, and they're low strength. It's pretty evident when these soils are worked when they're wet. They tend to rut. If you bring out a combine when it's wet, they'll sink. It's a lot tougher to deal with these soils. Adding organic matter does a couple of things. One, it increases the ability to hold nutrients. Secondly, it makes the soil a lot more forgiving. When it's described as a sponge for water holding purposes, that's also true for just the forgivingness of the soil, because as you roll over it, the organic matter will push down but actually rebound, whereas mineral soils won't. So the more you add, generally speaking, the better off you are. Again, they do hold nutrients better. The nice thing about organic matter is it has variable charges, both positive and negative, so it's able to hold a wide range of nutrients. So again, this is helping your bottom line as far as how much fertilizer you have to put on. Another thing is, you can see where the roots have moved down, but there's evidence in this soil here of where there's been plowing, disking, something has happened for manipulation pretty steady, right around 8 inches to 9 inches. And you can see that very sharp break between the two. And this is an example where as they've built up the roots and the organic matter, the color gets better and it's slowly starting to break its way through and move into the subsoil and begin to make it a more workable soil. As the roots push down, they're pulling the better topsoil with higher organic matter down with them. So not only are they pulling that organic matter down, they're making better structure by breaking through the subsoil. And another added benefit is the fact that you have the roots working their way down and bringing that organic matter, and that feeds the microbes. Microbes play a large role in soil structure formation. As they eat the carbon, they leave off all sorts of things, but it's generally gels and glues that hold the soil together to make better structure. As the structure increases, infiltration increases. As the soil is just a little bit drier, again, it's easier to traverse it without rutting. It gives you soil strength. It's what we're promoting really is a system. You want to disturb the soil less, keep it growing with cover crops, control where you drive over. All of these things go together to make a more profitable and workable soil for you.